Good afternoon, everybody. Me and my teammates are Matangi and Krishna Sai. We are doing Capstone project on performance evaluation of 5G MIMO-NOMA. Next, coming to the MIMO. So, multiple input, multiple output is a wireless technology that uses multiple transmitters and receivers to transfer more data at the same time. It has a technology that boosts the spectral efficiency through the use of multiple antenna technologies, which results in the significantly increase the network coverage, capacity, and user throughout the output. Next slide. So this is the process of NOMA, non-orthogonal multiple access. So here we can see that there are two users. Let us take the example of U1 and U2. Here U2 inform the information will be decoded by the receiver using SIC with the little loss of after eliminating a U1 interference. Then the U1 information will be decoded by the receiver directly due to high power strength. Here first the user requests the base station for the allocation of the resource. Then the channel state information CSI will calculate the distance between the base station and the user. After calculating the distance successfully, the power allocation and the resources will be based on the far and close distance. For instance, U1 sent to the U1 is sent to request the base station. Then as soon as the channel state information receives the request, it will calculate the distance. Next, Matangi will continue.
So this is the system model. As we can see that this is a MIMO transmitter. It is nothing but multiple input, multiple output. So there will be two antennas and each antenna will be sending informations to both the user 1 and user 2. Here user 1 is at a farther distance than the user 2. So user 1 we have considered it as a weak user and user 2 is considered as a strong user. So when the signal will be sent, it will be sent using superposition and from the base station to the users. Once at the receiver side, the signal will be decoded using successive interference cancellation. The user 1 is the weak user and user 2 is the strong user. So the user 2 will have the signal of the user 1 as well decoded, which will be considered as the interference. Next slide. So we have carried out this process for different models of antenna configurations. One is 2x2, 4x4, 8x8 and 16x16 respectively. So these are some of the equations which we have used for mathematical purpose. And then we have taken three main parameters into consideration. One is sum rate, which is the average amount of signals which is received by each user from both the antennas. And next one is the outage probability. It is nothing but the receive power where the receive power falls below the threshold. And next one is the user rate for each weak user and strong user is how much amount of power they receive. We have calculated it at 24 dBm. Next, Krishna will continue.
And coming to the simulation part, we have here we have simulated individual user rates, outage probability, and sum rates of NOMA-MIMO configurations of 2 into 2, which is here is the outage probability, the individual user rates, and the sum rates. And then coming to the 4x4 configuration of MIMO-NOMA, the outage probability, sum rate, and user rate are here. Here is the outage probability, the individual user rates of each user, under the transmit power of 24 dBm, and the sum rates under 24 dB. And here is the outputs of simulation of 8x8 MIMO-NOMA. The outage probability, the individual user rates, and the sum rate. And coming to the final output, the 16x16 configuration of MIMO-NOMA, we have simulated the outage comparisons, the individual user rates, and the sum rates. And from the above results, we have concluded that to get better sum rates and user rates, we need more transmitting antennas. Therefore, better the antenna configuration, better the performance of MIMO-NOMA. We have also observed, despite the use of techniques like direct detection and successive interference cancellation, The signal of a weak user becomes constant after a certain amount of time due to environmental signal interferences, which can be caused due to scattering or reflection. Thank you.